Hi, everybody. Welcome to Shuko Math Practice Lab, Learning Through Practicing. And today, we're going to start a new unit. And this unit is the second part of the limits units we talked before. So this units talk about the relation from the limits, continuity, and the differentiability. So we're going to talk about the three levels. So the first part of the practice ones here is we're going to take a look. So what is the, we call this discontinuity point? How do we find the discontinuity point? And what is the discontinuity point has anything to do with the limits here, okay? And so those are the four problems we are going to work today. And so the first two problems here is that we give you the functions, and then we want to see at any specific numbers A here, it is a continuous or is not continuous at the number A. And then the second group, we have two problems also. I want to find is this function have any discontinuity points in the given functions, and which number, we can say is continue from the right or continue from the left or neither here. Okay, so as always, right now is a good time to pause your video and get a pen and pencil out, pen and paper out, and try to work those problems by yourself first. And then, resume the video and we can check the answers, okay? So now is a good time to pause it, and I'm going to go to the whiteboard and I will talk to you in few minutes here. Hi, I'm back, and so let's start to talk about this continuity things. Okay, as always, right? Let's take a look. What is discontinuity mean? Let's do a brief review what you learned, and this will help us to define our first condition. If we say a function is continuous, what that means here? Okay, so I'd like to show you a few graphs, and hopefully from these few graphs, you'll be able to know what, how do we define. Okay, so for here, so for examples here. Okay, so, if I have a function go like this, and this is the number A, and this we call this L1, and this level I call this L2. So from this example, if you just look at the graph, obviously this is not a continuous, correct? You got to jump here. It's not a continuous. It's just by looking at the graph. So what thinks this is violate? Because this one's here, you see when the limit f of x approach to a, from the right-hand side, f of x, my limit is L2, right? And then if you say limit x approach to a, from the left-hand side, my f of x is equal to what? L1 here. So I know, oh, L1 is not equal to L2. So we did this in our limits units. So what is here? So we'll say the limit is what? Limit does not exist at x equal to a. So I know if limit is not exist, then it is, you will see a jump or some discontinuity there. So I know the first thing here, in order to say this function is a continuous. So first condition, we have to say limit has to be what? Limit has to exist, right? So this is the one of the condition in order to satisfy the continuous definition, continuity definition. Okay, so now let's take a look. You said, okay, you told me the limits has to exist. Let's take a look at these situations here, right? Okay. Okay, so this one's here. Okay, so now let's take a look, this one. So how about if I have a function, the same ones here, and this one's here, I call this is L1, and this is A. So from this problems here, you say, okay, this one's here, limit x approach to A plus, and or the A from the right-hand side, f of x, this is equal to L1. And the limit x approach to A from the left-hand side of the f of x, this is L1. Oh, so the limit right approach to equal to left approach. So I know the limit to A exists, right? So this is exist. So this is limit exist. So when we talk about the limited unit, we say the limit is as long as your right approach equal to left approach, right? So, but obviously from the graph, we still see a hole there. So we know, hey, this is not continuous. So I know I'm missing something. So that means my f of A value has to exist, right? So beside the limit exists, so I said, hey, the f of A, this function value has to exist. Okay, so you say, okay, now I know, okay, so this will be the conditions here. So I know limit has to exist, f of A has to exist. So let's take a look at the third situation. Then we finally be able to make the conclusions and find out. Okay, so for these ones here, okay, so let's see the same things here. So if I have a functions here, so this is my function. Okay, so this is f of x, and here I have, so this is A here. Okay, so if you take a look at these functions here, right? So you will say the limit x of A approach to from the right-hand side, f of x. Oh, I'm sorry, here, let's put this one level is L1, this number is L2, right? So then you will say here, okay, A approach to from right-hand side, this limit is equal to L1. And the limit x approach to left-hand side, this limit equal to what? L1. So very good, L1 equal to L1. So also I said limit x approach to A, f of x equal to L1, this is exist. And then you say from the second one, you say FA has to exist. I say, okay, here, the FA has to exist, right? So f of A in this graph, what is the value of f of A? Is L2. But, if you look at the graph, it's still discontinuous. So I know, okay, I satisfied FA exists. Still, it's not a, it still is discontinuous. So I can conclude, I said, f of A, even it exists, it has to be equal to limit x approach to A, f of x, in order to be, what do we say is a continuous here. So by combining these relations here, right, so I can write it down. So a function's f of x, if we say is a continuous, right? What are the three conditions? So we said the limit continues at a point A. So we say limit x approach to A, f of x. This number has to be exist. Limit has to be exist. Then we also say the function value has to be exist. Then even these two, by the graph number 3, we say even these two is not enough. So we need to say f of approach to A, f of x has to be equal to the function values here, right? So if a function is satisfied with these 3, then we'll say this is continuous. Okay, so remember this, right? So now we are going to use this principle. So we take a look at our problems here, okay? So for the first problem here, so this is a piecewise functions. I have an x squared minus x squared minus 1. And now I'm looking for, is the function at A equal to 1 is is a continuous or not. Okay, so now we say, okay, f of A has to be exist. So let's take a look at f of A is equal to f of 1. Oh, the piecewise function tell me f of 1 is 1. Good. Okay, now I need to see when the limit exists or not. So I will say x approach to 1 from the right-hand side of x. So this is limit x approach to 1 from the right-hand side. So this is x squared minus x. This is x squared minus 1. If you push the 1 in there, what you will have? You will have a 0, 0, right? So we know if you have 0, 0, we need to find some way to manipulate the numbers so we can get a definite answer. So here, then you take the x out. This is x minus 1. So this one is x minus 1, x plus 1, that's right? Okay, so now you can cancel x minus 1, x minus 1. So what is this limit here? This limit is 1/2 when x approach to 1 from the right-hand side. Okay, now let's take a look. Limit x approach to 1 from the left-hand side, f of x. So this is limit x approach to the 1. From the left-hand side, this is x squared minus x. This is x squared minus 1. So it's the same thing. You factoring. And then here, this is x minus 1. This is x minus 1, x plus 1. Right? Then in here, you cancel. And then your x equal to 1 from left-hand side, you equal. So you see here, these two are equal. So I know the limit x approach to 1, f of x equal to 1/2 exists, right? But unfortunately, this limit is not equal to f of 1, which is equal to 1. So I know when the a equal to 1, so when the x equal to 1, so this is what? So what here? So this is a discontinuity point, right? Because the limit is not equal to the function values here. Okay, so now the second one's here. Let's do the practice, the second one's here, right? So when a equal to 3, so the first thing's here, let's see if the function value exists. So f of a, so this is f of the 3. So what is f of the 3 here? Is 6, correct? Okay, so now I'm going to take a look at the limit x approach to 3 from the right-hand side, f of x. So this will be equal to limit x approach to 3 from the right-hand side. So this is a 2x squared minus 5x minus 3. This is x minus 3. If you put x equal to 3, it will be 0 over 0, right? So that's why you know you need to manipulate it a little bit and to get you the answer. So this is limit x approach to 3 from the right-hand side. Then I do a factoring on the top here. So the factor on top will be 2x plus 1. And I think this is x minus 3. Okay, now good. X minus 3, x minus 3 cancel. So what is here? So this is 7 here, right? So this is 7. And then the same way, if you want, you can say the limit x approach to 3 from the left-hand side, f of x, this is equal to limit x approach to 3 from the left-hand side. So this is a 2x squared minus 5x minus 3, x minus 3. So this one is equal to the limit x approach to 3 from the left-hand side. This will be 2x plus 1, x minus 3 is the same thing, you're factoring. So x minus 3, you will get 7. So you know these two equal to, so the limit exists. So f limit x approach to 3, f of x equal to 7, right? Because the left-hand side limit equal to the right-hand side limit. But unfortunately, it's not equal to what? F of the 3, which is 6. So I know the a equal to 3, this is a discontinuity point. Right, so because the limit is not equal to the function values here, okay? So now let's take a look. the next two problems here. So the next two problems here is want us to find what is the, where is the intervals of the continuous and, is right continuous or left continuous, right? So we know the exponential function is a continuous function, and this is a linear function, is a continuous function, roots function is a continuous function. So we know those functions, they are all continuous in the intervals they was identified here. The only possible one will be at those jumping points here. Okay, so now what we want to do is here, let's take a look at those jumping points here. First, the first ones here is x equal to 1. This is the jumping point. So let's take a look at what is f of 1. F of 1 is equal to 2 to the first power, so this is equal to 2, right? Okay, so now we're going to say limit. Now we need to say the limit x approach to 1 from the left-hand side. That means it's less than 1. So it's a 2 to the what? 2 to the 1s here, right? So this is a 2 to the 1, so this is equal to 2. Okay, so the same thing, you say limit x approach to 1 from the right-hand side, f of x. Right-hand side will be the 3 minus x, right? So this will be 3 minus 1. So this is equal to 2. Oh, very good, right? Limits equal. So I know the left-hand side limit equal to right-hand side limit. So limit x approach to 1, f of x equal to 2. Also, is very nicely is equal to the function values, right? So it's equal to the f of 1s here. So I know, so what is here? So f of x is what? Is continuous at what? At x equal to 1 here. Okay. Okay, that's great, right? Okay, now let's take a look at the second ones here. Now the second jumping point is f of, is 4, right? So let's say f of the 4. So with the equals here, f of the 4 will be 3 minus 4. So this one's equal to the negative 1. Okay, so now let's take a look and limit x approach to 4 from the left-hand side, f of x, so it means from less than 4. So what is here? So this will be 3 minus 4 is equal to the negative 1. And then limit x approach to the 4 from the right-hand side. So it will be root of x, right? So this will be limit x approach to the 4 from the right-hand side, the roots. So this is equal to 2. So I know the left-hand side limit here. Look here, the left-hand side and the right-hand side. This is left-hand side limit. This is right-hand side limit. They are what? They are not equals, right? So I know the limit. So the limit f of limit. So I should have said like this. So limit not exist at x equal to 4. So that's why is so it's not a continuous at 4. But look here. So this function value is equal to the limits I'm approach from the left-hand side. Okay, so this is not exist. So, but if in here I can say the f of x is what? Is a continuous from what? From the left-hand side, okay, from the left, right? So from the left, so it's not continuous. So it's from the left, it's not, so it not exists. So it's not continuous at 4. Okay, you guys see the differences here? So because the limit is not exist, so I will say limit, so it's not a continuous. Remember when we review, we said the continuous, the number, the 3 conditions here, right? Limits has to exist, function value has to exist, limit has to equal to the function values here, right? So I know the limit is not a continuous at x4, but because of the f of x is here, if you approach to the 4 from the left-hand side, from the one-side limit, they are equal. So I can say the f of x continues from the left. Okay? So the continues from the left at 4, right? So I can, that's maybe better from the left at x equal to 4, right? But it's not a continuous. Okay, so now if you still got confused, let's try one more here, right? So first one, x plus 2, this is a linear function, so I know it's a continuous. Ex is a continuous. 2 minus x is another linear function, is continuous. So I know the only thing could happen here is will be what? At those jumping points, right? So let's start to work on the jumping points here. Let's see what happens here. The first jumping point is f of 0. Okay, f of 0, 0 is equal signs here, so it's e to the 0, so this is 1. Okay, now let's take a look at the limit. The limit x approach to the 0 from the left-hand side. From the left-hand side is the first equations, right? So this will be the limit x approach from the 0 from the left-hand side, so will be x plus 2. So this will be what? Will be 2, right? Now, the limit x approach to the 0 from the right-hand side, f of x, that will be right-hand side, that means greater than 0, so will be the second equation. So this will be limit x approach to 0 from the right-hand side to the ex. So what is here will be 1. So now I know the 2 is not equal to 1, so the limit is not exist, right? So limit not exist at x equal to what? X equal to 0, okay? But now you also see here, because this is the function value is 1, and this is the limit, you approach it from the right-hand side, right? So limit is not exist, so I know f of x is not continuous at x equal to 0, but because these two, they are equal, so we'll say that f of x is what? Is continuous. It's continuous the right from the right at x equal to 0, right? Cool. Okay, now let's take a look at the next jumping point. Is f of the 1 here, right? F of the 1, so 1, the equal sign is on the second equation, so it will be e to the 1. So what is here? So it's e. Okay, so now let's take a look at limit x approach to 1 from the left-hand side, f of x. So this will be limit x approach to 1 from the left-hand side. It's less than 1, so it's the second equation, right? So it's the ex. So it's equal to e. Okay? Now limit x approach to 1 from the right-hand side, f of x. Right-hand side is the third equation, right? So this limit x approach to 1 from the positive sign. This is 2 minus x, so it's 1. Oh, too bad. So what happens here? Right-hand side limit is not equal to, the left-hand side limit. So what do we conclude here? So the limit not exist at x equal to what? At x equal to 1. So if limit did not exist, then what do we conclude here? We say f of x is what? Is not continuous at x equal to 1. Correct? Okay, so but now you take a look and you say, oh, this is the function value. Oh, this function value is equal to this function value. So by these two, I know because this is the one approach from the left-hand side of the 1. So I will say that f of x is what? Is continuous from the left, right? From the left at x equal to what? x equal to 1 here. Okay, so like, so first is here. So this is our first practice set, but on the practice set, that's why we demonstrated one very important concept, right? So that means the limit has to exist, right? So limit x approach to a, f of x has to exist. It's not only exist, it has to be equal to the function values here, right? So that's the one thing here we defined about the continuities, right? So be very careful. And what is the limit exist? That's what back to our limits units. That means if you approach from right-hand side, you approach from left-hand side, it should be equal, right? So remember, that's the one level we put one extra conditions for the continuity. Limit has to exist, and the function value has to exist, and they two has to be equal to each other in order for the function to be continuous. And that's it, okay? And so remember, for these ones here, you need to, find several other problems and try to practicing, right? And we know practicing makes you get better in the math. Okay, and now it's a good time to stop this video, and I'm looking forward to talk to you about our next videos here and how to find the interval of the continuous functions here. Okay, and have a good day, okay?